today we'll talk about the shape of data distribution. All right, lots of words here, but some important things. So we'll talk about shape. The shape of a distribution is described by symmetry, number of peaks, direction of skew, or uniformity. Symmetry. A symmetric distribution can be divided at the center so that each half is a mirror image of the other. The number of peaks. Distribution can have few or many peaks. Distribution with one clear peak are called unimodal, and distribution with two clear peaks are called bimodal. Unimodal distributions are sometimes called bell-shaped. Direction of skew. Some distributions have many more observations on one side of a graph than the other. Distribution with a tail on the right towards the higher values is said to be skewed to the right. Distribution with a tail on the left towards the lower values are said to be skewed to the left. Uniformity. When observations in a set of data are equally spread across the range of the distribution is called uniform distribution. A uniform distribution has no clear peaks, and we will look at some examples. All right, so here we have spread. The spread of a distribution refers to the variability of the data. Variability, if you think of the word vary, it means to vary, just like what it says. So it's talking about how much the data changes or is variable. If the data cluster around a single central value, the spread is smaller. The further the observations fall from the center, the greater the spread or variability of the set. So here you can see, here we have something that is less spread out. You see that the spread of my data is not that far from each other. I have from 3 to 7, and here is more spread out from, this looks like from 1 to 9. So this is more spread out. All right, the shape of a distribution is described by symmetry. So this is what we read before. The number of peaks, direction of skew, or uniformity. So here is an example of something that is symmetric. It looks the exact same on the left side and the right side. Is unimodal. We only have one peak, and it looks like a bell shape because they said when it's unimodal, we usually call it a bell shape. Here we have something that's skewed to the right. So notice that this tail here of the lesser or the smaller values as they're going down is at the right part. And then we have skewed to the left. Notice that the tail here is on the left section. So the smaller values are on the left. Uniform looks like all of the values are about the same. Here we have something that's symmetric, but is bimodal. So I have two clear peaks. So this is not bell-shaped. And then we have something that is non-symmetric and still bimodal. So here I have a peak here and a peak here. Notice that the peaks do not have to be the same amount, but there's still two peaks within the data set. All right. Unusual features. Sometimes statisticians refer to unusual features of a set of data. The two most common unusual features are gaps and outliers. So here we have a gap in the data. So between 4 and 5, there's no data at all. And here we have an outlier, and we've talked about it in previous lessons, how to determine what an outlier is and how to calculate an outlier. So here we have a gap and an outlier. All right, so let's do some examples, of course. It says paracellin. So we're going to use the cluster gaps, use clusters, gaps, peaks, and outliners in symmetry to describe the shape of the distribution. So if I look at first clusters, I can see that the data, there's no gaps, which talks about gaps, and so it's all clustering around between 31 and 39. So clusters are sometimes thought of as like a range. There is one peak, so it's unimodal. Unimodal, excuse me, and the peak is here at 35. There aren't any outliers, and it looks like it's symmetric. So if I cut right down here in the middle, it looks like it's the exact same on my left side and on my right side. All right, let's look at another one. It says use clusters, gaps, peaks, outliers, symmetry to describe the shape of the distribution. At the right, and I didn't put it at the right, I apologize for that. So if we look here, I can see that I have a tail here on the right side, so this is skewed to the right. I see that I have a peak here, so this is one peak, and it is from 1 second to 2 minutes and 30 seconds. There aren't any gaps and there aren't any outliers. Box and whisker plots. While you cannot identify gaps and peaks and clusters in a box and whisker plot because of the shape of it, you can still identify symmetry and outliers as well as describe the shape of the data distribution. So let's look at a couple of examples of box and whisker plots. So the box and whisker plot shows the number of visitors to a state park. Describe the shape of the distribution using symmetry and outliers. So looking at this box and whisker plots, it looks like the whiskers and the box are all equal distance. So from 50 to 70, that's about 20. 70 to 90, that's about 20. 30 to 50, that's about 20, and 10 to 30 is about 20. So they're all equal, so this is definitely symmetric. And I don't see any outliers. Let's do another one. So we got a box and whisker plot shows the distance of several airplane flights in feet. Describe the shape of the distribution using symmetry and outliers. So this one definitely is not symmetric. I have a skinny section here and a fat section here, and this fat section here is over to the right, which makes sense because I have this outlier here. So this is skewed to the right because of this big fat section here over at the right. All right. Well, why are we learning about this? Well, we learn about this because measures of spread of center and spread. So you can also describe the center and spread of a data distribution. The shape of the distribution tells you which measures are most appropriate. The mean and the mean absolute deviation are affected by outliers, while the median and interquartile range are resistant to outliers. If there are no outliers, the distribution is not symmetric. Excuse me, if there is an outlier. If there is an outlier, the distribution is not symmetric. So this is something, a little chart, flow chart to use when you're thinking about it. Is the data symmetric? If it's symmetric, that means it doesn't have an outlier, so that means that you should use the mean to describe the center, and you should use the mean absolute deviation to describe the spread of the data. If the data is not symmetric, you should use the median to describe the center of the data, and you should use the interquartile range to describe the spread. So let's do an example. It says the line plot shows the number of states students in Elisa's social studies class have visited. So here are the states that she's visited. Choose the appropriate measure to describe the center and the spread of the distribution. Justify your response based on the shape of the distribution. So looking at this, I can clearly see that there is an outlier. Remember, we do have a formula for outliers that is important to use, but this point is all the way out here. I have gaps in my data. I have unimodal, I have one peak here, and it is not symmetric. Let's look at the next one. It says choose the appropriate measures. Oh, I'm sorry, I didn't choose the appropriate measure. So because this data is has an outlier, which one do we use? Well, when we have an outlier, we use the median and the interquartile range. And in the previous lesson, we showed you how to actually find the median and interquartile range by looking at a dot plot. Excuse me, a line plot or a dot plot, they're the same thing. Choose the appropriate measure to describe the center of spread distribution. Justify your response based on the shape of the distribution. So here I have, looks like it's symmetric. Cut it right down the middle, looks the same on the left and the right side. It is it is bell shaped. However, I can see that it's bimodal because all of these are the exact same. There are no outliers. So the best measure to use would be a mean for the center and the mean absolute deviation for the spread. All right, here's another one. The histogram shows the wait times in minutes for entering a concert. Use clusters, gaps, peaks, outliers, and symmetry to describe the shape of the distribution. So here I can see that there is possibly an outlier here. So from 90 to 99 minutes, that's pretty out there. That's hopefully you don't have to wait that long. There's also a gap in the data. I can also see that there's a cluster between 0 to 9 minutes and 40 to 49 minutes. And I can see that if I look here, it's not symmetric, but there is a peak here at 20 to 29 minutes. Okay, dogs. It says a line. Oh, this is not a line plot. What is this? This is a box and whisker plot. It shows the weights up in pounds of several dogs. So these are not the dogs. It's just a picture. It says describe the shape of the distribution using symmetry and the outlier. So this little dot here is definitely an outlier. That's our symbol. It's letting us know it's an outlier. Otherwise, we would have it coming all the way out here. So this is an outlier. So if I'm using an outlier, I would use this box plot is the best thing to use because it's showing me my interquartile range and my median. So it gives me my median and it gives me my interquartile range. My median is 160 and the interquartile range is 180 minus 120. And so that lets me know the data set. Also, I have this fat end of my box on the left side. So that means that it's skewed to the left and it's not symmetric. And I hope that this helps.